good morning, good afternoon, good evening, wherever you're watching this from. This is Cornelius Lubinda with another video. Now in this video, we are now continuing. We are still looking at Calculus 2, which is applications of differentiation. Now in this video, we are going to tangents and normals. So for example, if you have a curve, okay? You have a curve like this. You have a curve like that. You should think of, first of all, look at the title. The title is saying tangents and normals, right? A tangent is a line. A normal is a line. So, if you have a curve like that, and then you want to find the gradient at a particular point, for example, at this point, then we actually, it's very hard to draw a tangent line on a board. Okay, let me say something like that. So that's a tangent line touching the curve at that point right there. So if we want to find the gradient of that particular point on that curve, we draw a line that touches the curve at that point only. Now, that line is called the tangent line. Okay? That line is called the tangent line. And the gradient that we would find is dy dx. So in differentiate, okay? When we differentiate, the gradient is there. How do we find the gradient? We use dy dx. So we differentiate and then we substitute the particular point. Maybe they have said x is equal to 1. That gradient we have found is the gradient for this line, and this line will give you the gradient for that point. Now there's another line that we can draw, a dotted line like that. That is perpendicular to the tangent line, called the normal line. It's called the normal line. What else do we have to know about the normal line? One thing is that it is perpendicular to the tangent line. So if they ask you to find the gradient for the normal line, since it's perpendicular to the tangent line, we are going to derive from this formula m1 times m2 is equal to -1. So the gradient for this normal line is going to be gradient, okay, which you can also substitute for m. Gradient or m is equal to -1 over dy dx. So -1 over dy dx. Let me write it here. -1 over dy dx. That's how it would look. That is the gradient for the normal line. So that's what we have to know about tangents and normals. Recap of the video. That if you have a particular curve, okay, a curve, and then they want you to find the gradient of a particular point on that curve, what do? You draw a line which touches the curve at that point only. You draw, and then when you find the gradient, which is you use dy dx to find the gradient, okay, that which you will find, if I've given you a particular point, is the gradient of that point that you are asked to find of, and it's also the gradient of the tangent line. Now, the normal line is perpendicular to the tangent line, and the gradient is when you find dy dx, and then to find the gradient you will say -1 over dy dx, the answer that you have found after you have differentiated. That would be the gradient for the normal line. You can derive it from this formula, and that's it about tangents and normals. Thank you so much for watching this video. This has been Cornelius Lubinda with another video, and bye-bye.